Hey, 11th graders. So, this is our last lesson on our hypothesis testing, and here's where we're going to learn about the t-test. A brief note about these notes is that we've got a lot to get through, so I'm going to try and go really fast so it doesn't take too much time. And I'm also going to try and show you something like this where I want you to write it down as I'm talking. So, you can always pause the video and try to write it out accordingly, or you can just write while I'm talking. Okay, so a t-test is essentially a test about averages. So that's a really key word when we talk about t-tests. Essentially, what it is we're trying to see if there's a difference between what we expect a sample to behave and how it actually behaves, and if the difference is statistically significant. It sounds kind of familiar to some of our other tests, and so I just want you to keep the word averages in mind. If it feels like the story that's going on is talking about the averages of something or the general idea or a behavior of a sample, then we're talking about an average. On average, it's behaving this way. On average, it's not behaving this way. Comparing two classes tests results, using a medication to lower your heart rate, seeing if the heart rate before the medication versus the heart rate after the medication, are the averages different, statistically different enough for us to say that it actually makes a difference. So that's a general idea of what a t-test is. Calculator instructions, there's a lot of variation that can happen with a t-test. The first variation that we're going to talk about is whether it's a one sample t-test versus a two sample t-test. All of your textbooks only talk about a two sample t-test. I have seen once one problem, not on an IB exam, but on a resource that somebody else had made for IB, that somebody had put a one sample t-test in the material for this class. And just on the off chance that it's expected to be in this class because the guide is not clear, I've decided to include the one sample t-test in these notes. But just be aware that for the most part, you're only going to see two sample. One sample test you can see at the very bottom of this page. That's example number 2. You can see at the bottom of the page where it has only one line of data, and it's because you only have one sample. And you're looking at this one sample and you're saying, does this sample have this average? We've been given an average and a standard deviation, and we're saying, does this sample follow what we expect that average and standard deviation to be? Versus a two sample will have two samples that we're comparing. And you can see that in example 3 as well as example 4, where you're given two rows of data, and you're trying to see between these two samples, is there a difference on average between them? You can see that we've got a medical cream trying to see if the heal time has changed before versus after. You can see two schools comparing scores between the two classes to see if on average the scores are different between the two tests or between the two schools. So that's what we mean by a one sample versus a two sample. Your null hypothesis is always going to be that the average is equal. With a one sample, it's that the average of your one sample is equal to the number that they tell you it should be. So you can see down here in example 2 that it says a population with a mean of 34.5. So your null hypothesis will be that the average of this sample is equal to 34.5. Notice that how we write the null and alternative hypothesis is very different with a t-test than it is for a chi-squared test. Chi-squared test is very wordy. T-test is very symbolic, a lot of math. It looks more mathy. So you do actually write it like this, but you actually put the specific number that we expect it to be. So for one sample, it's that your sample is equal to that average. And then your alternative, you have 3 options that you can do. You could either say, okay, the sample's average is not equal to the number that we thought it to be. The sample's average is greater than the number we thought it was going to be, or the sample's average was less than the number we thought it was going to be. How you determine which of these alternative hypotheses to use is in the text. You have to look in the problem to see whether they say, we're testing to see if they're different, we're testing to see if it's greater, we're testing to see if it's less. So you'll be able to be told that in the text, and we'll practice it. It pretty much follows the same for two sample t-test, where it's the average of one sample is equal to the average of a second sample. And so kind of that same idea of your null is always just equal. Versus alternative, again, you have those options, not equal, greater, or less than. And again, you look to the text that the two samples are not equal to each other. One sample is greater than the other sample, or one sample is less than the other sample. You will every once in a while see these words thrown out, two-tail versus one-tail. Two-tail means that it could either be greater or it could be less, right? There's two tails to this question. It could be that they're bigger or they could be less. So that's what we mean by a two-tailed test versus a one-tailed test would be like we're only looking at the greater thans or we're only looking at the less thans. Not something that we're often asked about in this class, but every once in a while I've seen a problem where they're like, what is this, a one-tailed or a two-tailed test? And you will just have to know that if it's like multiple options, two diversions, that's a two-tailed test versus if it's only greater than or only less than, then it would be a one-tailed test. Calculator instructions are then broken up even further into more categories. You'll notice when you go through the calculator steps, at some point you're asked whether you were given data or whether you were given statistics. Depending on whether you were given data, which you can see in examples 2, 3, and 4, where you're given a table of numbers, that's all data. Example 5, while you are given a table, it's a table of statistics. It's a table of mean and standard deviation. So you've been given the statistics on the sample. You haven't been given the whole sample. Obviously, it's an easier test to run if you like in that example, in example 5, it's 50 flowers. You don't want to type in 50 numbers into your calculator and put in all of the raw data. So instead, you put a summary of the data, the statistics of the data into your calculator to run the test. So, depending on whether you're given data or whether you're given statistics, you're going to enter this into your calculator differently. For data, we will be using the spreadsheet. You have to put in your actual data into the spreadsheet, then you run the test following these instructions. Depending on whether it's a one sample test or a two sample test, you'll divert. So it's either option number 2 or option number 4. Then it will walk you through things that you need to give them. It'll ask you, where did you put your data, all of that, and we'll go through that accordingly. Versus, one quick thing is that at the end, very end of the list, it will ask you if it's pooled. It automatically says no, but we always want it to be yes. So just remember that you always need to say yes on pooled. So you need to go all the way down in all the options in your calculator in order to say, yes, we want it pooled. Stats. Stats is not using the spreadsheet because you don't have to put in a list of data. So you don't have to go to make a spreadsheet at all. You just have to run the test on your normal calculator screen. So this is it's now our second test that we run not on a statistics list or on a spreadsheet list. So you just go to a normal calculator if you're given the statistics, like example 5. You go to your normal calculator, go find the tests, and we only do 2 sample with statistics. We will not be doing 1 sample with statistics. So you will only go to the 4th option, which is 2 sample. It'll walk you through, we'll talk about this when we get there, but just realize that X bar means average, 1 means the first sample. So it's the average or the mean of the first sample. And then standard deviation of the first sample, and then the sample size of the first sample. And then you'll see below it, it'll say 2, 2, 2, and that's just for the second sample. Again, it needs to be pooled. And if you haven't finished already, go ahead and pause here and try to fit all of this information under here. Notice, because of the length of these notes, I've cut out example 1. I don't think it's important. So if you want to use some of that space below, you're welcome to. Okay. So let's go ahead and start actually doing this to see what all of this means. So we are going to move on to one sample t-test. Again, please remember that I don't think we're going to be seeing this much at all, but it's pretty straightforward. It's not too difficult. Just being able to spot it and be like, oh, this is the magical, mythical one sample t-test and feel confident on being able to apply it is my goal. If it ends up not being used at all, then at least you were prepared. Okay, so the sample below is thought to have come from a normal population with a mean of 34.5. Test this belief at a 5% significance level. So, like with all of our tests, we're going to start with our hypotheses. This is a one sample t-test because I've only been given one sample, right? I'm not comparing two different samples. I have a sample and I'm comparing it to one mean. So, I know that my null hypothesis, looking at my work up above, is going to be that my average is equal just to the average that we thought it was going to be, which is 34.5. Our alternative, then, we have to look at the text to see if it's trying to test whether it's bigger or less or anything like that. They haven't used any of that wording here, right? It says just the sample below is thought to have come from this. So really, we're just testing, is it this? Does it have an average of this? And so then the alternative would be